Hello, everyone. Good morning, good afternoon, good evening. Sorry, we are a little bit late here. We were just trying to resolve some technical difficulties with Kubernetes and making sure we were ready for the stream to go live. We are going to be continuing off our journey into Istio. I have Rohit over here, myself, Marino, and we're going to dig into some of the core functionality of Istio. In the last stream that we did, sorry, I'm adjusting my camera. Last stream we did, we actually went ahead and we installed Istio into a cluster that's running on the Civo cloud provider using the Civo Kubernetes service. And so it took us probably about an hour to get to that state. Now we're at this point where we can start configuring a variety of different features in Istio and whatnot. So Rohit, why don't you go ahead and pull up the Istio documentation and where we left off from last time?
Yeah, I guess my screen is already sharing, so let's move forward directly to our Istio documentation.
Yeah, sure.
So as everybody know, like we were in the setup. So after setup, we use the getting started, and then we had did our documentation, and we had deployed already book config, right? Book system. It was here. No. Other platform, many
Yeah, it's the book info application.
yeah, book.
Yep.
Yeah, this product page we was doing. So history injection, kubectl get services. Yeah, we had done this, right? Ingress host and ingress port.
Yeah, so I mean, if you run a few of any of these commands, I don't know if we got this far. I think we did manage to deploy the app itself and whatnot, if I'm not mistaken. So
Yeah, we can check also, right?
yeah, so let's go review the current status of the app right now in Kubernetes, and then
First, let's check our
yeah.
get
So
pods.
I will say, Rohit, you may need to increase the font size on your screen because it might be a little small for people to read. Right now, it's a little small for me.
Okay, 1 minute. Mm, we have to increase the size of rows, I guess.
So there's a few things you can do. You can just hold the command function on your keyboard and just press the plus button on your keyboard as well, and that should increase the font size. Yeah, exactly, exactly. That's so much better now. Hey Kumar, how's it going? Welcome, welcome.
Okay, so while running the pods, we can see like we had this product page, ratings, reviews, everyone's there. So let's check our product is running or not.
You may not have.
So
So one thing about that that command you're about to run, right? It's referencing an environment variable that you haven't set locally on your system.
right, right.
So you'll have to set that up ahead of time. So you may need to go back and backtrack because remember, I set this up on my terminal, and now you'll have to set it up on yours. So uh, what you can do is there's a command. If you scroll down, actually scroll back down a little bit.
Should I increase the size of a screen here also? It is
No, no, no,
visible.
no. I think this is legible. Okay, so
Okay.
there is a command that is actually going to take the services and port IP information and assign that to a variable. I think it's further up. You'll have to go a little bit further up. It says you know where it says determine the ingress port IP and port on the right hand side there.
Yeah,
Click that link.
yeah, it is here.
Okay. Um,
Do we have this YML? I guess I'm not having it.
no, it's already deployed though. We've already
Yeah, we have deployed it. Yeah, right.
yeah
So we need to export directly, right?
yeah exactly. So the thing is, it won't like there's nothing to export because we haven't quite defined the variables yet. Like, so ingress host and ingress port aren't defined. If you echo those right now, they won't return anything.
Right.
So we have to go and assign those as well. So what I recommend is you'll probably need to go in and get that information. So kubectl will get, you should be able to get the services and then the associated ingress port IP.
Yeah, services we have like which one we need? Product page or Kubernetes cluster? Hello, am I audible? So what actually Marino was saying?
Sorry, that was like something that just came into my room, so I didn't
Yeah,
want y'all.
yeah, yeah,
All right, so here's the thing, right? None
yeah,
of these
yeah.
services are going to be exposed externally. So the way we did this was we used the ingress gateway to do so. So remember, the ingress gateway is like our gateway entry point into the cluster. So where did we deploy that? We actually deploy that in the Istio system namespace. So if you look here, all of these services are cluster IP, meaning they don't have an external IP, they're only internally accessible. However, because we have an ingress gateway available, we will use the ingress gateway for routing traffic inbound from the external world. If I was making a request, it'll hit the ingress gateway on a certain port, and then the ingress gateway knows, hey, I know I need to get to the product page service, which doesn't have an external IP, but I know about the service anyways because it's internal. I can communicate with that internal service. So you can think of it this way. The ingress gateway has a leg to the external world as well as a leg to the internal mesh.
Right.
Okay, so it has a foot in both worlds. Now, that being said, you will want to get the services located in the Istio system namespace. So if you run that command again, but append the -n Istio -system, you'll see the ingress gateway come in.
CTL
Yeah,
slash n, right?
yeah, get services -n Istio system.
Yeah, ingress.
See the load balancer IP there, 212.2.243.9, and then you only really need the IP information, the port information, which is 80.
Yes.
Okay, so we have those two pieces of information. All we really need to do is export the gateway IP and the gateway port or the ingress port. So we'll run an export command and then type in ingress, all caps, underscore host,
Dollar. No,
dollar
no.
sign,
Yeah, yeah, yeah. Yes.
underscore host equals, and then 212.2.243.9.
Yeah.
Okay. Yep. Hit enter. And then we're going to run the export, and then we're going to also append the port. So ingress port equals 80.
Okay.
And then we're going to do one more as well. Export
Yeah.
secure, all caps, underscore ingress, underscore port.
This is for.
I'll tell you in a second. And then equals 443.
Okay, 443. Got it. Got it.
Okay, so let's explain that to the audience. Why are we doing
Yes.
this?
Yes.
So why are we doing this? Do you want to explain that?
Yeah, so it is like we had specified the one of the outbound connection at the start, which we prepare for the what we say when we create the subnets. So we prepare one of them for the outbound rules. So one of them we use here to get it connect the outer source with our ingress. So I guess that's why we use this for the secure purpose, secured ingress connection with the outbound.
Well, so let's clarify that a little bit more. When you
Okay.
are listening on port 80, you are just basically listening for unencrypted,
Yeah.
no certificate traffic. So any unencrypted traffic can make a request. If you don't have a certificate, that's fine. You're unauthenticated, and you can go ahead and make that request.
Right.
Now,
Right.
because we've specified the secure port, when you make that request, you have to make sure that you're also affixing a certificate to that request so the authenticator can verify that you are legitimate when making this request. If you are not allowed to make this request because you don't have the right certificate, the request will just get rejected or denied, and you will be returned with a HTTP 403 forbidden or something along those lines. So the reason why we just did this is because initially we're going to access this application using unsecured HTTP. The next time around, we're going to use the same URL except using port 443 to access it using the certificate or using it using HTTPS. So that's the reasoning for having that in place. Um,
Yeah. Also, it is the same reason why we get the kubectl fail type of errors. So many times you will get the forbidden kubectl error. So this is the reason.
well, the not necessarily right. Like sometimes that kubectl error that you receive forbidden actually might mean that your kube config file doesn't have the right certificate data. So if it doesn't have the right certificate data, it can't authenticate against the kube API server.
Yeah, but it is before the cluster creation. But when we have already the cluster, then I guess it is due to this only, right?
What do you mean?
Before before cluster creation, many times we get the forbidden error. So that
Well,
is
that's
due to the config error. That is due
well,
to the config error. Yeah.
exactly. Like the config doesn't point to any cluster,
Yeah,
or
yeah,
it doesn't
yeah,
have the
yeah.
correct configuration to point to a cluster. So, all right. So let's move forward. I think let's get now if we do an echo of the gateway underscore URL. So echo dollar sign gateway underscore URL.
Oh,
No, yeah,
yeah,
nothing.
yeah. We have not exported it yet. Let's export. Yeah, it is there.
Now it's there. Perfect. Now, now you should be able to access that using the curl command. No, there was a
Yeah, I
curl
guess
command.
I. Yeah, I guess I will paste directly. So it is here. What was that curl command? Yeah, this one, right?
Yes, that's the one.
Let's enter.
Okay.
Yeah, we got it.
Okay. Okay. Perfect. So now we should be able to continue on a little bit more. Um, so that being said, you should be able to move forward with what's next. So we have a destination rule. Okay, so we're already accessing the system,
Yeah.
so we can already access
So
the application. Yeah.
yeah, we can directly do it on our system also, right?
Yep.
By adding the that.
Hmm.
Yeah, it's there.
Yep. That's perfect. Okay. We've basically done the quick verification just to make sure this is working. The next thing we want to do is making sure that we can now move forward with the destination rules.
Yeah, it is also saying like you can
Yeah,
refresh it automatically every time.
that's
Sorry,
right.
not automatically. You can refresh it anytime, and it will show you the different type of reviews.
Yeah,
So it is like it is scaling every time. Yeah.
it's not scaling. It's actually so. Let's go back and look at the application for a second. So if you open up the terminal and if you look at,
Balancing, right?
well, yeah, it's balancing but not scaling. So go,
Sorry,
yeah,
wrong word.
yeah. So type in kubectl get pods. So if you look here, right, there are three different versions of the reviews service: reviews v1, v2, and v3,
Oh,
right? So each one of those versions will output something very differently as compared
different.
to just having one. What's actually going on is because the sidecars are in place, the sidecar can identify that there are three different subsets in the destination rule. The
True.
three different subsets will basically dictate, hey, this is version one, version two, and version three, and it's going to be equally load balanced. And that's why you see a round robin setup in terms of like whenever you hit the refresh of that page, you'll get a different result every time because it's just randomly, picking whichever one is available to respond appropriately. Now, um, that being said, like there's a lot of different things we can do with this, and we can even go in. I think we already applied a destination rule. So if you type in kubectl get destination rule, no rule,
Hyphen.
all one word, and hit enter.
No resources.
Okay, type this in dash Istio. Sorry, in the Istio system namespace. So rerun the command with a dash n Istio system. Okay, so we didn't create a destination rule. Why external IP takes so much time to come up in the case of Ingress Gateway? So if you're spinning up an Ingress Gateway locally on your own system, and you're using a cloud provider, it actually might be a delay of the cloud provider provisioning a load balancer. So here's a very brief mechanism of what goes on. You deploy a Kubernetes cluster, and let's say that cluster is deployed onto a cloud service. Let's say it's Sivo. Now, there are underlying hooks to get to different services inside of Sivo, and that's usually provided through the Cloud Controller Manager. It might be called something different today, but I'm pretty sure that's the same name that is used in Kubernetes in the control plane. Now, what occurs is whenever you spin up an application and then you define a service, and that service says, type load balancer, even if it's an Ingress gateway, for example, Kubernetes has to tell the cloud controller manager, which has to tell the underlying cloud provider to spin up a load balancer. So now the cloud provider has to go out and spin up that load balancer, and it may take a few moments for that load balancer to come online, and then for the logic to be set up correctly so that an IP can be allocated. So this could be just a delay upstream on the cloud provider side, and I've seen this with Google Cloud. I've seen this with EKS and Amazon or AWS, and I've also seen this with Sivo as well. But it's just a mechanism because it's going to take some time for that load balancer IP to come online. Now, in other situations, like if you have complete control and access to a lot of this underlying hardware, you probably can shortcut and speed up that process altogether, removing inefficiencies in the way like your applications can come online. Because this delay definitely can be detrimental to running in production, especially if you don't have an IP available quickly in time. Your requests routed at a global level might not make it to the destination as intended because the IP is just not there yet. So, anyways, that being said, let's move on. Great question, by the way, Kumar. Let's move on. So we're going to apply destination rules. So we'll just copy that command. Oh, by the way, you didn't install Istio. So because you didn't install Istio on your local system, right? One of the challenges that you're going to run into is that you don't have the files locally here. So you actually
I
have to.
guess I guess I have, but let's check again.
Yeah, because you also want to make sure you have the right version of Istio,
Okay.
CTL, right? So be very mindful about the version of Istio that you're going to run and install, because the last thing you'd want is the wrong version.
Which version to use then?
I can't. What do you recall? What version we installed last time? I don't even remember now.
I guess we directly use these commands. We didn't did any separate kind of installation.
Okay, so then yeah, so I think you can just run the curl command up top there.
Yeah,
Yeah, because all it'll do is it'll just download the correct version according to your system.
and we did that pro check command to
Yeah,
compare it. Yeah.
no problem, Kumar. Okay, so you ran the command. Oh, before you do that, before you change the directory, can you export that path exactly? All the way, yeah. The entire command, run that command. Okay. Now, before you continue, type in, before you continue, type in which Istio CTL. Which Istio CTL. Perfect, okay. So we now know it's pointing to that. Now type in Istio CTL. No, don't type that command yet. Istio CTL version. So what this will tell us is, okay, so you will have to change your version of Istio CTL to 1.13.7. So what you're going to have to do is you're going to have to reinstall Istio CTL. So let's go back to the documentation page. And yes, we're going to use that command and choose the specific, we don't need that piece. We just need the
Yeah, that's
specific
right.
version. So copy the entire command, and then remove the target arc section, and then change the version to 1.13.7.
Yeah.
Yep, hit enter. And then the export command that shows up, run that command, and then we'll just verify that it's using the correct version of Istio. And then, okay,
No,
it's still using, okay. So what we can do is we can actually remove this. So if you type in rm-r, and then that entire directory.
from here, right?
No, yeah, if you just take that entire directory, it'll target it towards that directory. And then remove the, remove the istio-ctl bit. You can actually remove the entire, well, actually, it should be gone now. So if you type in which istio-ctl, there we go. Okay, now if you type in istio-ctl version, hey, perfect.
Got it.
Okay, done. All right. Now you can type in istio-ctl x precheck. And this should work just fine. Excellent. Okay, so now we can go back to the original part of our process and we can continue what we were doing. So
Yes.
if you you might have to change directory in your terminal, but that's okay. We'll do that afterwards. Oh, we didn't do a
Just
bunch of other things. We skipped a bunch of other things. So
yes. In last the Istio analyze we didn't did.
Yeah.
Uh,
So
Did we did this?
you can run an Istio analyze if you want.
Yeah, I guess it should not give any problem.
Yeah.
Actually, I love to run this Istio CTL and Minikube commands. They have nice visualization.
Yeah. Okay. So no issues. All right. Let's keep going. We already ran the export stuff, so we don't have to worry about that anymore.
Yeah, right.
We verified external access. Okay. Now we need the dashboard. Okay. So run those commands. What we're going to deploy is the Kiali dashboard. So run that one command, kubectl apply -f. And it may not work because, no, hold on. It may not work because you're not in the Istio CTL directory or the Istio directory. So you might need to change to cd istio 1.13.7.
Oh,
Yeah, that's one way. The other way is you could append the directory to the kubectl command. But once you hit enter, it'll take you to the directory, and then you can rerun that kubectl command. I don't think you have it. You might have to copy it. Oh, yeah, there you go.
so we are using Kiali, right?
Correct.
I guess Kiali is now the favorite for every Istio people.
Kiali is, yeah, it's a really great tool. I don't know how much it's used in production though, because a lot of companies have developed like much more enhanced dashboards.
True,
Anyways,
true.
Kiali should be ready to go. But the way to get Kiali up and running is you have to run the istio-ctl command, the dashboard command. So let's go back to, let's check the status. So there's a kubectl rollout status command. Let's run that. Okay, so it's been rolled out. So there's an istio-ctl command you can run there. No, yeah, it's right there. Exactly. Okay, so it looks like we do have Kiali up. So if you go to the graph section now,
Yeah, first of all, I would like you to tell our audience like what is a honeycomb.
I'll get to that in a second. So let's go to the graph
Okay.
section. Yeah,
Graph. Yeah, yeah. No
and then
namespace.
let's select the namespaces. Ignore honeycomb, just select Istio system and default. No, ignore honeycomb, Istio system and default.
Any version type.
No, that's fine. So I'll point out a few things, right? Because you asked about it, honeycomb is just a namespace that Kiali picked up when it actually spoke to the Kube API server. I was actually doing some testing, so there's just some sample apps in there, and it has really nothing to do with what we're doing here. At some point, like I will get like honeycomb to work with Istio, so I can get some telemetry data. But what we're doing here is that Kiali is going out to scan the Istio system namespace and realizing, hey, there are no sidecars here, so I don't really care about the traffic here. But it does care about the traffic for a namespace that does have sidecars, which happens to be the default namespace because we injected sidecars the last time around. Now, there isn't much traffic going here, so we're going to have to go and generate traffic towards our application. So what you might want to do is maybe open up the app again, like you have the app open somewhere, right, in one of your tabs. Do you have the app open in one of your tabs?
Which app?
The Book Info app.
Yeah, yeah, it is here.
Yeah. Okay, so hit refresh several times. And if you notice when you keep hitting refresh, you see how the stars are changing? They're changing color.
Yeah.
So what's
Yes.
going on there is we're going to each one of those different reviews service, right?
Yeah.
So the rating service is just telling us the actual rating. The review service is actually visualizing differently for us. So it'll call on the data from ratings, but then it'll display either no data, or it'll display stars in black or stars in red. So keep hitting refresh, like constantly hit refresh, like just keep doing it, because I want to generate enough traffic so that we can go back into Kiali when you're ready. Okay.
I guess it's enough.
Yeah. So let's go to Kiali now.
Oh, where I have lost it.
It should be in one of your
One,
tabs.
1 minute. Huh?
Yeah. Maybe it's Safari. Okay. That wasn't there before, right? But if you
Yeah.
think about this, so here's what's going on. Traffic is coming in to the Istio. Actually, we could even make this a little bit more enhanced. Uh, yes, Kumar, you are absolutely correct. It is the same Twitch stream honeycomb. Shh, don't tell anyone. All right, so if you hit so in the middle pane up at the top, you know where it says namespace, and right below that it says display. Hit the display drop down and scroll down until you can see traffic animation, right?
Yeah.
As well as security. Scroll down, security.
Yeah.
Okay. And now what I want you to do is change on the right-hand side, change that last 1 minute to 15 minutes. No, last 1 minute to 15 minutes or 30 minutes. And then doesn't matter. That's okay. 30 minutes. And then I think you can reduce the refresh time to every 5 seconds or 10 seconds. 10 seconds is okay. Okay. So you can see the flow of traffic. Do you see the flow of traffic and where it's going? Do you see those animation bubbles?
Yes.
So what this is telling us is traffic is entering into the ingress gateway that is listening externally, right, on port 80, for any traffic going towards that particular IP address. Okay. So it's listening for traffic on that port. When it receives a request on that port, it's going to forward on that request to the product page. Now, the product page needs to capture information from other services. So the product page is going to capture information from the details page, or the details service is going to capture information from the reviews service. And the reviews service is just going to round robin to each one of its versions, right? It's going to round robin to either version 1, 2, or 3 and return values back to product page. Product page is going to render that information in the form of a web page, so we see it visually like we've been seeing it before. But this is that microservices setup. This is the book info application. And as an extension of this, we're able to see all of this data because the sidecars exist, because Kiali is able to take that information from the Istio Ingress Gateway, because it's a proxy that exports metrics in Prometheus style, as well as spans and data in Zipkin and Jaeger format. But because it's able to send this data to Kiali takes it, and then it looks at the other sidecars for product page, for reviews V1, 2, and 3, and for ratings, and even details, and says, give me your data. I'll take this data and then present it to you as you're seeing here on this map, because it's now telling us this is the flow of traffic. This is where traffic is going, and all of the different interdependent services it needs to hit before it renders that result we just saw, is effectively how this all works. So the sidecars are doing something very interesting for us. Now, they're sending telemetry data that Kiali can pick up on and then give us this visualization of how our traffic is flowing. But the sidecar is also doing something else. You see that lock icon?
Yeah.
Between each, or on each one of those lines? That is indicative of the fact that MTLS is enabled.
Okay.
So MTLS is enabled, which means that there is encryption between each of those endpoints, which then means, okay, if I have encryption, my security posture is in place, right? Now I can ensure that traffic going across the wire will be encrypted, cannot be read in plain text or anything along those lines. So here's the interesting thing, right? We entered into the system, we accessed this application unsecurely on port 80, right? Everything beyond that is securely accessed. So even so, like we don't have to authenticate our requests from the external world. We can change that. We can actually modify that, and we're actually going to do so like now. We're actually going to make that modification so that our ingress gateway is now looking for secure requests coming inbound. So let's go back to the documentation. Let's head back. Unless you have any questions about Kiali that you want me to talk about.
Yeah, so I would like you to talk about this. So, as you know, like you were talking about the sidecar and mutual TLS. So,
Mhm.
can you be specific, like what these things are doing in our system?
Yeah, so the sidecar is deployed. Actually, let's pull up the terminal for a second.
Yeah.
And what I would suggest you do is probably hit Control C because you'll probably lose it. We can come back to it in a second.
Okay, sure.
All right.
Yes.
Okay. Now let's do a kubectl get pods. Okay. In normal deployments, when you start out with Kubernetes, you deploy an application, you'll only ever see 1 out of 1 under the ready column. Most of the time, you'll see that. When you deploy Istio or a service mesh, you'll see 2 out of 2, especially if the namespace has been labeled. So remember last time when we were in this environment, we actually labeled the default namespace, and we can
Yeah.
verify this if we type in kubectl get namespaces or get ns. No, hold on, not done. Hit up arrow
Oh, I you
dash
have
show
like
labels
okay. Which one you want to take?
dash show labels. Sorry, dash show dash labels. Okay, so you see how the default namespace, right? The default
Yeah.
namespace has a label saying Istio dash injection equals enabled. That is telling the default namespace anytime a new pod is instantiated or created, deploy a sidecar alongside that. Okay.
Okay.
So that sidecar deployed means that now Istio D, the Istio control plane, is aware of the fact that it can do very creative routing, observability, and security with that application. So what really goes on with the sidecar is that the sidecar is responsible for all kinds of traffic communications. It's the proxy for the main container. Normally, the main container would do all the direct interfacing with other applications, but you're sticking a proxy in front of that. So now you have 2 applications, and then you have 2 proxies that need to communicate with each other. They'll talk to each other, but the applications won't talk directly to each other. The applications will use the sidecar proxies to communicate, which allows you to then inject that layer of identity, to then be creative with how you decide, hey, I want to route to this service and not that service, or that pod, not this pod, and then how we can export those metrics from the sidecar into Kiali as well. Without the sidecar, we lose a lot of that rich data or rich telemetry. So Kumar has a question. On the Kiali dashboard, why are we not able to see the egress gateway even though it's there in the cluster? So Kumar, the reason why you don't see the Kiali, that's right, the reason why you don't see the egress gateway show up in the Kiali dashboard is because there's no traffic actually going through the egress gateway right now. What has to happen is that we actually have to make a request, and it actually has to flow from the inside out through the egress gateway. Now, why would we use an egress gateway? There's a few reasons. One primary reason is that maybe we want to filter any sort of outbound external requests that go out, and we want to do so securely. So let's just say we're accessing an external database or an external DNS-based service. These are external services, and we have to define them inside of Service Mesh or inside of Istio to tell Istio, hey, we can be allowed to access these services. We can instantiate traffic requests from inside our cluster and go outbound. but we use the egress gateway to control the flow of that traffic, to make sure that we can verify certificate information and maintain TLS all the way through to the exit point. So you can kind of think of it as like when you think of traditional routing, you have a router that accepts inbound routing requests, and then at the same time, that same router might be used for traffic leaving the network. In our situation, we split that functionality up between an ingress gateway and an egress gateway. I hope that makes sense.
Right.
Okay, so we've talked a little bit about the sidecars. We've covered off the Istio CTL command, dashboard command to give us Kiali. Now we're at the next steps. So right now, we can move on to a few different areas. We can do some request routing. We can do some fault injection. We can do some traffic shifting. Where do we want to go? Let's start with request routing.
Step by step.
Yeah.
Mm,
Okay. So before we start anywhere, let's start at the very top. Right? We always want to read these things top to bottom because we don't want to miss a thing. So before you begin, we want to set up Istio by following the instructions in the installation guide. So that's already done. We need to deploy book info. That is done. And we need to review traffic management concepts doc before attempting this task. Okay, so let's go and review traffic management concepts first before we dig into this task. So there's a few key elements that we need to be aware of with respect to traffic routing. So let me explain them. So we'll start off with the sidecars. We've talked about sidecars already and what they do for us. They allow us to facilitate mutual TLS between services, but they're also a point where IstioD can provide routing configuration directly to this proxy or to this sidecar to tell it, hey, if you need to get to this other application, here is the routing table to get there. Here's how you get there. Here's where it's located. Here's the DNS information. Go have fun. Is exactly how this works. Mitesh has a question. So before I continue, and hey, Mitesh, thanks for coming by to the stream. So your question is, can we get Jaeger tracing out of the box through Istio? Yes, we can. And quite honestly, it's actually already up and running and available to go. So
Yes.
you deploy Istio and you deploy the sample add-ons. Jaeger is deployed as part of that sample add-ons. All we have to do is just turn on the Jaeger dashboard, and then we can go and look at a trace, and then the spans inside of that trace. And then what we would normally look for is to maintain the entire trace, look for the B3 header information that is consistent through every single span. The B3 header information just basically says, if you get a whole bunch of spans like out of order, here's the way to reassemble them for this trace. Here's the way to tie them to this particular trace. And you can even see this in Jaeger as well, real time when it gets into it. Your other question is, do we need to do a change in Istio sidecar? No, you don't. It's already ready to go. Istio already reads Zipkin and Jaeger formats anyways, so it's ready to go. Any blog or article explaining it in detail? There are tons of blogs talking about tracing, spans, and more so around Istio and Jaeger. Simple Google search. I will look up some blogs on the back end, see what I can share with y'all, so that you have something on record. Now, continuing on, right? Traffic management really depends on two key routing pieces: the gateway as well as the sidecar resource. Now, at a high level, a gateway will receive traffic from the external world and forward that on to a resource that needs to provide some information or a response. What you need to do is the gateway will then tell that sidecar resource, hey, I have an inbound request. Can you respond to it? The sidecar resource will then go to its main application container, get the response, and then provide that response back to the gateway, who will then return that response to the client on the outside. Now, Earlier, or not in the stream, but the last stream we did, we actually defined virtual services, and I think we went on to try and define a destination rule. But let me explain this quickly. So a virtual service is like a set of routing rules. How do I get to each one of these different services using this host name? So I have a host name, and then I have all of these different paths I want to get to in this host name. Now, that's one part of it, right? You're telling different objects and resources in this environment how to get there. Now, once you get there, what happens? Like, what do I want to do? Do I want to route just plainly and cleanly, or do I want to load split? Do I want to share my traffic across 3 different versions or subsets? And this is where the destination rules come in. The destination rules are kind of like a policy that you put in place for your routing rules to say, when this traffic arrives at this destination, what do we want to do to it? If these requests come in, how do we want to handle these requests? Do we want to distribute these requests across 2 different versions? Hence why we saw reviews v1, 2, and 3. And if we wanted to do this, we have to define subsets. So we'll define our subsets in a destination rule and say, hey, this subset is v1, this other subset is v2, and the third subset is v3. Now, in these various subsets, we'll define how much traffic is going where. And that's going to be specified. If you actually go down to the destination rules, keep scrolling down. There should be something about, okay, here we go, right here. So you see how there are different weights, 25 and 75. So, sorry, I wish I was sharing my screen because I want to share this and talk a little bit more about it. Let me share my screen.
Okay, sure.
And I'll pull it up in a second here. Yeah, given how much time we have left, okay, all right, let's go take a look here. So I talked a little bit about the virtual services and the destination rules. So when we look at a virtual service example here, right, it's pointed towards the Istio API, and it's an actual container, sorry, not a container, it's a custom resource definition that Kubernetes can understand. So if you look here, we're specifying what host this is, right? And in our case, it's the reviews host. And we're going to actually match on a particular header. Like, we can ignore this for now, because we'll revisit this another time. But this header information is just really something more specific. We'll use header information to be much more direct in our request. What this is saying is, if I am trying to communicate with the review service, as long as I have the header, HTTP header with a string that says JSON in it, I'll be able to fulfill my requests. Now, as I mentioned, there are routing rules that take place here, and you can see all the different kinds of routing rules as well as the weights that we can put in. But if we go over to our destination rules, if we don't specify a destination rule, this won't really truly work. So let's take a look at our destination rule here. So the destination rule here is, again, another container, sorry, not a container, why do I keep saying container? It's a custom resource definition that Kubernetes understands, but it's something of Istio. So when you actually go into Istio, or if you type in kubectl get crds -n Istio system, you'll see all the different custom resource definitions that do show up. But if you actually look at this destination rule here, right, we're basically saying, hey, this is my destination rule going to my service, and then we're specifying a traffic policy to do a random load balancer selection. Here are the different subsets we've defined and the associated version tags. So we're looking for this version tag, which will basically align with the service and its particular version, or the review service. And this is our traffic policy specifically for version 2. It becomes round robin. So it's kind of interesting how this rule is all set up. But you need both a destination rule as well as a virtual service configuration to make this all work. Because one, remember, virtual services is telling you how to get there. The destination rule is being a lot more specific. And when you get there, this is what we're going to do to the traffic. This is what we're going to do to the requests. And this becomes extremely important. Now, that being said, right, you need resources to be able to process this traffic and the requests. Now, the gateway is the best place for traffic coming inbound. And once you've deployed a gateway, you will associate that gateway with a virtual service. The virtual service is just specifying, hey, I want you to receive requests for this host. And this is the gateway that is going to receive those requests, which we've defined right here. And because of that, now we can start making requests towards x-host.example.com. Now, to be more specific about this, right, we know how to get here. What if we needed to specify, hey, I've got two pods or two backends. They both do the exact same thing, except one is version 1, version 2, the other one is version 2. How do we distribute the traffic? Well, if we go back to the destination rule example here, we have to define our subsets. And then we also have to go into our virtual services configuration and define weights for those subsets. Now, without these two, again, you won't be able to properly load balance across your different versions. But with these two, you'll receive requests on the gateway, and you're basically now saying, hey, I know how to get to this resource, and then I know what to do when the requests come in to that resource. How will I route them? How much will I route to them, etc. But that's effectively what traffic management is. You can get actually very granular here. And if you look further down, you see there's timeouts, retries, circuit breakers, fault injection. This is actually how you build resiliency in your microservices. Because here's the other thing you have to consider. Not every service is going to respond at the same time or in the same amounts of time. And because of that, you may witness delays in your request. Now, here's the thing. You have to tune your different services accordingly in accordance with how quickly they respond to that request. So if we go back to the book info example, right here, product page has to make a request to either reviews V1, V2, or V3. Now, if it's round robining, here's the problem. If V1 has gone down and product page has made a request to V1, it has to now make another request to V2 because the request to V1 failed. So this is a delay. Sorry, not a delay. This is actually a fault here. So it needs time to make that request all over again. So it'll run a retry for that request. If that request fails again, it'll try to retry again, or maybe return value saying this resource is unavailable. But we can actually tune that much more to continually retry until the V1 service comes back online, or it may even pick up another resource. Now, the reason why I'm bringing this up as well is because for whatever reason, the reviews V2 service might have a special configuration that disallows an immediate response, which means the product page might be waiting, and then it might time out on the request that it's trying to make to reviews V2. We can actually implement some sort of buffer to tell it to wait accordingly for the reviews V2 to return a response before it decides itself, hey, this thing is timed out, it's not going to ever return a response. And the reason why this might happen is because V2 might be responding to requests for other things, and it might just be overworked at this point. And so maybe this is a situation where the Kubernetes horizontal pod autoscaler will scale the V2 service or the V2 reviews pod and may have another pod to respond to requests, and then product page cannot get the response it needs. But this is where we start getting a lot more advanced with traffic management in Istio and whatnot. So we kind of jumped around a little bit, but what I really wanted to illustrate here is that we have our app up and running. It's the book info app. Rohit verify that it's online. We accessed it using an unsecured port. We talked about virtual services and destination rules, and now we're at this, and we even reviewed Kiali and what it's providing. Now we're at this point where we really want to play around with traffic management, but we're pretty much at the end of time here. So I will say we will continue this. We'll do this again. We have to schedule it. We'll set it up. We'll continue this journey because now we're at this point where we're trying to get interesting with our traffic management. We want to get granular. We want to take advantage of timeouts, retries, circuit breaking, fault injection, and even working with external services so we can see how we can build a very flexible, resilient services environment. Let me answer Kumar's question, as well as Mitesh. Okay, Mitesh mentioned that you got stuck here. It's possible that you have missed something. So what we can do is next time we'll go in and take a look at Jaeger and see what that looks like and get that up and
Okay.
running, so that maybe like you said, you might have missed something and you'll watch us get it up and running and it could work. Kumar's question: we are calling service as host in this case. I always thought host as a separate instance. Okay, so just to kind of create some clarity here, when I refer to host, I'm really talking about host name, which I'm also talking about a domain name. Okay, so google.com or xyz.ca or solo.io are domain names, and they lead to particular locations. Solo.io leads to our website. Now, when I call that a host, that is a host. It's looking for requests to respond to, and we'll define that in our virtual services configuration as well as our destination rule to tell, hey, if you're coming here to get to solo.io and then the academy page, well, you'll route through the solo.io page first. Solo.io will call on the academy page to say, hey, someone's making a request to you. Can you give me some details so I can render this data for you? And the data will be rendered, and then we see it. But the host in question is solo.io. That's what we're targeting. And then we can specify a whole number of URIs that we can get to. Now, that being said, we have reached the end of our time here. So we did cover a number of things. We reviewed Kiali and how traffic was flowing inside of an Istio environment with Bookinfo deployed. We verified that Bookinfo was up and running. We also just dug into things like virtual services, the sidecar resource, the destination rules, and what gateways are doing. The next time we stream, we'll talk a little bit more about these different traffic management features as well as service entries. If there are any more questions, feel free to ask them in the chat. Rohit, any final thoughts that you want to share?
Yeah, we are listening. I guess my voice is repeating.
What's that? I can hear you.
Okay. So I guess we covered a lot of points today, and it was really helpful session. So it really helped me to also like learn various things. So thing is like, let us know in the comments like how regular you want us to be on live. So as we are traveling and all stuff, so we will remove our time sometimes and get it back to you. So we are uh, we had committed you to be weekly session, but we missed our last week session. So sorry for that. So for future, let us know how frequently you want us to make these sessions, so to cover the entire Istio journey. And so thank you for attending, and yeah, Marino is our rock star.
No, you're the rock star, man. I'm just here to just reaffirm that I know what I'm doing and sharing all those details with you as much as I can. By the way, Mitesh, I've actually dropped some details in the chat here for Jaeger and Kiali, in case you wanted to.
I have one plan, I guess,
Yeah,
Marino. We can
yeah.
create some Notion document or ClickUp document, and where we can share the links during our sessions. So
Hmm.
people will have that one link where they can find any resources for the entire Istio journey. What do you
Hmm.
think about this?
Perfect. Yeah, yeah. Go for it. Let's get that information out there. Kumar has one more question. Let me take that question. Ingress gateway will forward the traffic to, let's bring this up here. The Ingress gateway will forward the traffic to virtual service, and then it will forward it to particular service based on destination rule. Um, yes, so I'll explain that a little bit more. The virtual service is just telling the Ingress gateway where the resources or the actual service pods exist, or the pods themselves exist. So it's more like a set of rules or like a set of directions. Like, think of it as like, I'm going to tell the Ingress gateway, here's your map to get here. The destination rules are going to be a little bit more specific about the different versions that you might have for that service. So if you say I have a review service, that review service inside of it can, as long as these pods have the same label, the review service will route to each one of these pods. But here's the interesting thing. When you specify the review service inside of a virtual service, the virtual service doesn't know yet that there are 3 different pods with the same label. So you actually have to go in and define those 3 different pods as subsets inside of the destination rule. That way, it tells the virtual service, hey, even though you're targeting this particular service object, there are 3 different backend pods that are labeled appropriately for the service to load balance to, if that makes sense. So this is why we need the destination rules in case we do have multiple versions of our service. But it's an interesting way to load balance it. And this is how you make it work. We'll dig in a little bit more next week. But I, again, want to thank everyone for coming here, learning with us in public. This is fun. I love doing this stuff. I know Rohit is enjoying and learning things as Rohit's going along. So yeah, let's get back at it. We'll do it again very soon. I just got to figure out the travel schedule and yeah. All right, everyone. Take care. Have a great evening, great afternoon, great morning, great night, wherever you are. We will catch up soon. See ya.